If you want to randomize any value within Control Rig, you can use the noise node. So right click, search for noise, and this will generate random noise. So in this case, what I'm going to do is search for draw transform, just to draw a box. And in the translation, I'm going to do an add vector. So the position I'm going to put it in is 0, 200, 100. So that puts it here, and you can change this to a box because I found that more visible than the axis. And what we're going to do is from the noise node, the result, we're going to plug that into the z-axis of the B. Set the maximum to, let's say, 40. And now it's moving randomly between 0 and 40 and adding it onto this original vector. And we can change some of these values. So for example, let's change the speed. So now it's quickly moving between 0 and 40. And also what you can do is plug it in directly to a vector. So if we create a new noise node, you'll see that this is grayed out and it can be plugged into any value. So I'm going to plug it into B. And now what we're doing is generating noise for a vector. So you've got 3 values for each of these. If you want to have a position that you can manipulate from within the viewport rather than typing in numbers directly, go to the Rig Hierarchy tab, right click on any bone, go to New, New Control. If you scroll down, you'll see it's created a new control that you can now manipulate in the viewport. So if I wanted to draw this transform wherever this is, all you need to do is drag in this control, do Get Control, drop down the transform, get the translation, and plug that into the translation. And now it's drawing a box where this control is. If you want to make a bone, point at any location. So for example, let's make his head, look at this control. What you can do is search for aim and use the aim node. So connect the execution path. The bone, we're going to select the head. The target for the primary axis is going to be the translation of this control. So that's the target. If you drop down secondary, the target for the secondary axis, this is the up axis. So 0, 0, 1000 to put the target somewhere up in the air. And now we need to set the bone axes. So to find the axis values, what you can do is go to the skeletal mesh that you're using, search for the bone, press W to go into the translation mode, and you should see these arrows. So the direction that we want to align with the target is the one pointing forwards. So in this case, it's the green arrow. And if you look at the bottom left, you can see that's the y-axis. So the primary axis wants to be the y-axis. So under primary, the axis should be 0, 1, 0. And the secondary axis, the one that's pointing to some point above his head, should be aligned with this, which is the red axis, which is the x-axis. So now we want the secondary axis to be 1, 0, 0. And now you'll see that his head is perfectly tracking this control. However, rather than just having his head track it, let's make his body move as well so that he doesn't go into any awkward positions with his neck. So to do that, what we can do is duplicate the aim node. And instead of using the bone as head, we'll use the bone as spine 03. And we need to set the target. So for under primary, the target that it's facing should be this control. And now you'll see that his body is now locked to this target. But due to the order that we've done things in, first it sets the rotation of the head, which accurately points at this, but then we're also adding additional rotation by rotating the chest, which in turn rotates the head even further. So the head is now no longer tracking it because it's moving too far. So a simple way to fix this is to reorder these nodes so that it first sets the body, the span 03, because that's lower in the hierarchy, and then sets the head. So a way that you can reorder it is control click on the execution path and drag it to the new node that you want it to be hooked up to. And this works the same in blueprints. And now connect the aim node which deals with the head. And now you'll see that his head is tracking this point and so is his body. However, his body is moving quite a lot to track this point. So what we're going to do is change the weight of the one that deals with the spine 03 bone. So let's set a value of 0.25. So now the chest is only tracking by 25%. So what you'll see is his head is perfectly tracking the object, but his body is only doing some smaller motions to track it. Let's say that rather than tracking an individual point, you want to apply some rotation to a chain of bones. So not just one individual bone, but multiple bones. So for example, all of the spine bones. What you can do is right click and search for distribute rotation. And connect this up through the execution path. And this gives you a list of items. So if you click plus, you can manually type items in and then plus again to add the next item and so on. But an easier way to do this is to right click and search for item chain. Click on item chain, and the first item we want, let's say that is spine 01, and the last item is his head. And now it gives us an array of items that we can plug into the distribute rotation node. So from items, plug that into items. And now what we need to do is set the rotation amount for these items. So click the plus, and this gives us a rotation input. And this is a quaternion, which is harder to deal with than an Euler angle. So we can drag out from this and do from Euler. And this gives us a simple XYZ that we can manipulate. So let's say, for example, put 5, so 5 degrees on X. And that's going to apply to every single bone in this chain. So you can see that he's rotated more than 5 degrees, but each individual bone is only doing 5 degrees of rotation itself. So for example, if you wanted to make him rotate 90 degrees and you put 90 in, you would see that he gets into quite an uncomfortable position because every single bone in the chain is rotating by 90 degrees rather than the total. So what you can do is if you divide this 90 by the number of bones, and maybe we don't know the number of bones, so what we can do is drag out from items and do num to find the number of bones, and let's just add in a print node, plug in this value, and we'll see it's printing the number 8. So we know that there's 8 bones within this chain, so now we can get rid of that print node and the num, we don't need that. So what we're going to do is 90 divided by 8, and now you can see that he's rotated by a total of 90 degrees. And if you ever have a quaternion, but you'd rather deal with Euler angles, what you can do is the inverse of this node. So you drag out from the quaternion and do 2 Euler. And now this gives you the XYZ. And then you can do another one of these, so from Euler. And you can plug in the XYZ. But after plugging it in, what you can do is you could modify one of these values. So let's say on the Z-axis, you could just add a value to this. So let's do 25 degrees and then plug that into Z. And then you've got a quaternion back. So it starts with a quaternion, you do some modification as an Euler angle, and then you've got the quaternion back again. An important thing to keep in mind within control rig is that any values that you enter in the graph are assumed to be in rig space. Rig space is relative to the character rig that you're working with. So the character is at 0, 0, 0 in rig space. However, that's not the same as world space, which depends on where the character is in the actual world. He's still at 0, 0, 0 in his own rig space. So relative to the character, nothing's moving, nothing's changing. He's still at 0, 0, 0. But the world space value is changing because he's moving around in the world. So just to demonstrate this, we can create a print node. And what we're going to do is right click and do to world. And what this does is takes a value which it assumes to be in rig space, although you could incorrectly plug in a world space value. So it takes the rig space value and converts it to a world space value. So if we drag out from world and plug it into this print node, and then select vector, so it's printing the transform rather than a quaternion. This is taking 0, 0, 0, rig space, and printing out the world value. However, you'll see it's still printing 0, 0, 0 because in this world, in the viewport, he's at 0, 0, 0. So if we go to the game and simulate, you'll see that it's printing a different value here. This is where he actually is in the world. So when we move this around, you can see that the value's changing. And the inverse of this is the from world node. So if you have a vector which is in world space, like we do here, you drag out and do from world. This converts it from a world space value back to rig space. And it says global, and global and rig space are the same, which may get confusing. I'd usually just try to remember it as rig space is where the rig is, world space is in the world, and I forget all about global, ignore that. So this takes value from world space and converts it to rig space. So now if I plug this in as the value, we've got the 0, 0, 0 here, but also we'll have 0, 0, 0 here when we simulate. You'll see that no matter how I move the character, his rig space value and his rig space position 0, 0, 0 is still 0, 0, 0. Because all we've done here is taken a value of 0, converted it to world space, and then back from world space to rig space and printed it. So we've not changed anything here. But these nodes are very useful if you're wanting to save values in world space. So for example, with some procedural animations, you may want to lock one of the feet in world space rather than relative to the rig. So you would save the value as a world space value and then reapply it in the next frame and the next frame and so on. So then it will be locked in world space. So wherever you moved it in the world, the foot in this case would be locked in one place relative to the world. So when you're working on complex rigs with a lot of systems, sometimes it's useful to be able to actually see what's going on. So what you can do is search for draw, and you'll get some options for things you can draw. So the most common ones that I use are the draw transform node, which I showed earlier, which just takes a transform input. And the other one I use is draw line, which just draws a straight line. So the way this draw line node works is that it will just draw a line from A to B. So whatever you plug into A and whatever you plug into B. And remember, as I said before, this is in rig space. So 0, 0, 0 will be here at the center of where the character rig is. So let's draw a line from there to 500 units in front of the character down the y-axis. So that may be useful for some debugging purposes if you plugged in, say, a variable and plugged it into B to see what direction that was relative to the character. But when you simulate, you can't actually see where that line is. And that's because there are two commands that you need to enter into the console to be able to see the debug drawing whilst in the actual game. So in the console, type a.animnode.controlrig.debug space 1. And then, if you're using Unreal Engine 5.3 or probably greater, you want to type controlrig.enable draw interface in game space 1. And now when I do that, you can see that this line gets drawn. If you're at all familiar with control rig or blueprints in general, you'll understand the idea of variables. So within control rig, on the My Blueprint tab, you can click the plus icon to create variables. However, you may want to access information from outside of control rig. So for example, the actual actor may want to pass some information about the world into control rig so you can use that in your animation or your animation rig. So to do that, once you've created a variable, you can name it whatever you want. So I'm going to call this position input. On the details panel, tick instance editable, then compile and save. And now in your animation blueprint, click on the control rig node that you're using. And on the right hand side, you will see tick boxes for anything that is instance editable, as well as any controls you may have created. So now if you tick use pin for position input, so now you have a pin where you can pass any values you want. So for example, in the event graph, you may get the character. So you do try get pawn owner, cast that to whatever your character is, and then you read some value. So let's say you read a vector value, promote it to a variable, and now you'll see that that variable is here. And then in the anim graph, you've got this copy of the variable here. So you can drag it in and do get whatever the variable is and plug it in. And now that value will be accessible by control rig. So what you could do is drag in this to get the value that's been input. And let's say you had a print node, you could just print this value by plugging it in. So that allows you to manipulate any values you want from within the actor blueprint. And then the event graph will pick it up from here, then make a copy of the variable. And that variable in the anim graph gets passed through to control rig, and then control rig does whatever it wants with that. If you're making anything complex within control rig, you're likely to run into some errors at some point, especially if you're dealing with procedural animation that have a lot of arrays and doing complex logic. And the most common one that I see is that when you do the at node, and this is the equivalent of get from Blueprint, so you have an array and you want to get the value at a specific index, you'll get this error where if you hover over it, it will say array index and then whatever index you've entered out of bounds. Now what this is implying is that this array does not have a value at index 56, and in my case it actually doesn't, so it's correct. But if you're sure that this array does have that entry, so for example you might on construction, you may have done a loop where you've looped through 100 times and entered values or added values to the array, and then in the forward solve you're trying to print that or use that value and you get this error, and you're certain that you've set it up correctly. What you should do is restart the editor. This is a very common issue and the fix almost always works. And this applies to any errors that you get. Sometimes you'll get some weird errors where things just aren't working right, especially if you've been changing variables, renaming them, switching them to arrays, creating them in construction and then modifying them later. Whatever the error is, If it seems a little bit weird and you're quite sure you've not done anything wrong, restart Control Rig or restart the editor and see if that fixes it. Something that's very useful with any programming is the ability to create loops. So loops will execute the same code multiple times. So for example, you just do a for loop, connect it to the execution path, it will run whatever is connected here as many times as the count is set to. So let's set the count to 10. It will run whatever's connected here 10 times and then go down the completed path. But something to note about Control Rig, which is a little bit different to what you'll be familiar with from any programming language or blueprint. If you create a function, it has the end trait and return. And if within this function you have a for loop, you need to make sure that you connect the completed to the return node. What this means is that it will only return on complete. So you don't want to connect it to here because this is the body of the loop where it's executing this multiple times based on whatever this count is. If you connect it like this, you'll now get an error in 5.3, and that wasn't there before, saying linking a function return within a loop is not recommended. So don't do that. Normally, within most programming languages, if you return whilst in a loop, it will just break out of the loop and exit the loop. However, within Control Rig, you need to do it on completed. Otherwise, it will return this function multiple times. So whenever you call the function, it will exit this function multiple times. So anything that comes after will be also actually contained within the loop. So make sure it's always on completed after you do a for loop within a function. And whilst we're on the topic of loops, if you enter a value that's quite high for the loop count, so let's say 2000, you'll get this error on the bottom right, instruction has hit the node run limit. So what you can do is go to class settings and search for node run, and you'll see the node run limit, 256. So you can increase this value and that will fix the issue. However, you should probably try to avoid loops that exceed this value anyway. So try to keep loops to a minimum where possible because loops are slow. And if you're going to use large loops, it's probably better to do that on construction where it only runs once rather than on forward solve where it's running every single frame. At some point when you're creating a rig, let's say we've set up what we had before where the head tracks this point. You may want to see what this looks like when the character is in a different pose. So rather than just the default A pose, you might want to see what it looks like when he's playing a different animation or a different pose. So what you can do is go to the preview scene settings on the right, and on preview controller you can drop down this and choose reference pose or a specific animation. I usually use specific animation and click that. Then underneath you've got the option for the animation. So here you can go on the drop down from the animation and look through all of the animations that are related to this character. And so let's say we click on the MF walk forward. So now you can see that the character's walking forwards, and we can look at how the head is tracking the object and make sure the chest rotation is not too dramatic. And you might think, well, it's not obvious enough that the chest is actually rotating, so I'll change the weight value, and then you can see what that looks like with your animation. And it gives you a better sense of how the character will actually look in game using whatever settings you've got. So it's important to often just check different animations to make sure everything looks right. And sometimes you'll find that this resets by itself and you have to keep setting it. I don't know why that is. Maybe that's a bug that will be fixed in future versions. Keep in mind that this animation setting that we've just added is only for a preview within Control Rig. This isn't changing anything about the rig or anything about the character. It's only helping us preview it. If you actually wanted to make the character be using this pose whilst the rig is running, what you would do is go to the animation blueprint, and in the anim graph, you would add the animation, whichever animation you want, and plug that into Control Rig. So whatever comes in through the source, it then modifies it within Control Rig, and then it will output the result. So you can use the same animation as the preview if you want, or you can test other animations that may be within state machines or any more complex animation blueprint setup. And whatever you do with that, once you plug it into the source, it will modify whatever's input, make the changes, and then continue the output. So if your Control Rig node does nothing at all, then whatever is passed from the input will also come out at the output. It can often be useful to create a lot of controls all at once. So from the Rig Hierarchy tab, what we can do is we can shift select multiple bones. So I've just selected the first, shift click the last, or you can individually control click different bones. And what we can do is right click on those And from here, we can do new, add controls for selected. So that will add a control for each one of these bones. And if you scroll down, you'll see that you've got the same hierarchy, but as control bonds. So at the bottom left, you'll see that there's a span 0, span 2, span 3, span 4, and span 5. So you've got all these controls, and they're all created in the position that they were in based on the bones that you selected. And what we can do is select any of these controls, go to the details panel, and you'll see a drop down for shape. So here you can change the shape of the control. So for example, I'm going to change this to a circle underscore thick, and then I'll change the scale of this control. And now you can see that you've got a control in the shape of a circle. So you can set the control to anything you want, just decide what makes the most sense for whatever this control is actually controlling. So for example, for IK bones, I usually use a box because then you can see the transform quite clearly. And for rotations, I use circles and sometimes spheres and so on. So just choose whatever's appropriate based on whatever this is actually controlling. A useful tip to speed things up if you're dealing with a lot of bones, so for example if you're dealing with all of these spine controls or all the spine bones, is you can select them all, drag them into the viewport and click Create Item Array. And this automatically fills in this array with the items you've selected. So rather than you having to manually select each one, it will just give you an array. So in this case we could drag this out and put it into a distribute rotation node or anything else that deals with multiple items, so for each, and so on. And as mentioned, this works with controls, and you can also select bones and drag them in, do create item array, and it's selected all the bones that you've dragged in. Thanks for watching, and let me know in the comments if you'd like to see similar videos on topics like this.